Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR Enterprise Core exam. In this lab, we will configure DTP on switch 1 and switch 2 and examine the results. The lab instructions are fairly simple. Try out various combinations of these modes: access, trunk, trunk with no negotiate, dynamic auto, and dynamic desirable. Then confirm the results with show interfaces switch port and show DTP interface. In this video, I won't go through every single possible combination, but I recommend that you spend some time in the lab getting familiar with the results of each combination. We'll also check switch 1's connection to PC1, an end host that doesn't send DTP frames. Then, in steps 3 and 4, we'll do packet captures to analyze the DTP frames sent by the switches. Let's get started by opening the CLI of switch 1. Enable. Let's examine the default state of its G00 interface connected to switch 2 with show interfaces G00 switch port. This command gives information about the administrative and operational mode. Administrative mode means what you configured on the interface, and operational means the actual current state. So in the default administrative mode of dynamic auto, the port operates as an access port. The default administrative encapsulation is negotiate, but notice that the operational trunking encapsulation is native. That just means that frames won't be tagged on this port, because it's an access port. By the way, if a switch only supports .1q, the default administrative encapsulation will be .1q, not negotiate. If only one encapsulation is supported, there's nothing to negotiate. It's common for modern switches to support only .1q, but these iOS L2 switches support both .1q and ISL. Okay, now let's check show DTP interface G00. Let's focus on these top two lines, TOS, TAS, TNS, and TOT, TAT, TNT. Those are the operational, administrative, and negotiation settings for the interface state, the top line, and the encapsulation type, the second line. The interface is in dynamic auto mode, so it says auto here. It negotiated and operates as an access port, because switch 2 G00 is also in the default state of dynamic auto. And note that, as I mentioned in the lecture video, usually the operational and negotiation output will be the same. I have occasionally seen them be different when changing settings. We may encounter that in this lab or not, but just keep in mind that under normal circumstances, the O and the N columns should be the same. There's no need to examine switch 2. Its output will be the same as switch 1, so let's try another combination. I'll configure switch 1 as dynamic desirable. Conf T, interface G00, switch port mode dynamic desirable. Now let's check the output again. Do show interfaces G00 switch port. The administrative mode is dynamic desirable, and now it is operating as a trunk. Auto plus desirable makes a trunk. And let's check do show DTP interface G00. Okay, same information as the previous command. Next, I'm going to go to switch 2 and manually configure its G00 port as a trunk. Enable, conf T, interface G00. However, if you want to manually configure a trunk port, you have to disable encapsulation negotiation. So let's configure .1q here. Switch port trunk encapsulation .1q. And now make it a manual trunk. Switch port mode trunk. Now let's check do show interfaces G00 switch port. Now the administrative and operational modes are the same because they are manually configured. Trunk and trunk. .1q and .1q. And let's check do show DTP interface G00. Notice that a manually configured trunk shows an administrative status of on in this command. Now I want to try something. If I disable DTP on this port, what do you think will happen? Switch 2's side is a manual trunk, and switch 1's is in dynamic desirable mode. Let's try. Switch port no negotiate. And once more, do show DTP interface G00. Okay, administrative status has changed from on to no negotiate. Now let me hop on switch 1, which is using DTP still, and check its status. Do show DTP interface G00. Okay, it's still operating as a trunk. However, look down here at access timer expiration. This timer is 300 seconds by default, and resets every time it receives a DTP frame from switch 2. However, if I keep refreshing this command, note that the timer does not reset. Switch 1 is no longer receiving DTP frames from switch 2. So what do you think will happen when this timer expires? I'll pause the recording here and start it again once the timer has counted down. Okay, the timer has counted down, and notice there are these two log messages on switch 1. Received .1q BPDU on non-trunk G00 VLAN 1, and blocking G00 on VLAN 1. Inconsistent port type. So what happened here? Switch 2 G00 is a manual trunk port. Switch 1 G00 was a trunk port also, because switch 2 was sending DTP frames before. But after configuring no negotiate on switch 2, switch 1 stopped receiving DTP frames. When switch 1's timer counted down, switch 1 G00 stopped being a trunk. It became an access port, and then STP detected the port type mismatch and disabled it. Let's confirm that with do show spanning tree. Notice that G00 is in the BKN state. This means broken. There's some problem, and that problem is stated here. Type_inc, which means type inconsistency. Let's fix that by enabling DTP once again on switch 2. The command to re-enable DTP is no switch port no negotiate, which removes the previous command. Now let's return to switch 1 and see what happens. Do show spanning tree. Okay, G00 is no longer in a broken state. It's in listening and will eventually move to learning and then forwarding. Let's check do show DTP interface G00. Okay, it's a trunk port again. So we'll stop step 1 here. When doing the lab yourself, I recommend experimenting with all of the different combinations of administrative modes, but for this video, we'll leave it here. I'll go back to the lab notes for step 2. It asks, what trunking encapsulation is used for switch 1's connection to PC1? Without using the command, what do you think it will be? PC1 doesn't send DTP frames, so G01 should be an access port. We saw this earlier when switch 1 G00 and switch 2 G00 were both access ports. The encapsulation should be native. Let's double check on switch 1. Do show DTP interface G01. Okay, as expected, it's native, meaning frames aren't tagged over this port. It's an access port. I'll return to the lab notes again for step 3. Examine the DTP frames sent between switch 1 and switch 2. Which VLAN are they sent in when using .1q? How about when using ISL? Change the native VLAN and examine the results. So the link is currently using .1q, because switch 1's encapsulation is negotiate, and switch 2's is .1q. Let's do a packet capture on the link to see how the frames are tagged or not. First, I'll click on Settings and raise the limit to 500. Then I'll start the packet capture. Since there will be a lot of STP messages, I'll type DTP in the search bar to view only DTP messages. We won't check the contents of the messages, I just want to see if they're tagged or not, so I'll just view the messages here in CML, instead of opening them in Wireshark. And here are some DTP messages. Notice that there is no tag. When using .1q encapsulation, DTP frames are sent in the native VLAN, meaning they are not tagged. What about ISL? I'll stop and clear this packet capture. And let's go on switch 2. Let's change G00's encapsulation to ISL. And I'll show one example where the negotiation type and operational type are different in the output of show DTP interface by using the command immediately after. Let's see. Switch port trunk encapsulation ISL, and then do show DTP interface G00. Notice that the negotiation type is ISL, but operational is .1q. That's just because I used the show command immediately after the configuration. If I do it again, do show DTP interface G00, now they will be the same. So, as I said before, when everything is stable and working properly, these two should be the same. Okay, let's do a packet capture again, and filter it to show only DTP frames. What I'm expecting, and what I said in the lecture video, is that these frames should still be untagged, even when using ISL, because the native VLAN is the default of 1. The native VLAN is a .1q concept, not an ISL concept, but this is the behavior I've seen in my labs. And as you can see, in these DTP frames, they are untagged. Okay, I'll stop this packet capture and clear it. Now I want to test one more thing. What if we change the native VLAN on this link? I'll go on switch 2 and do that. Switch port trunk native VLAN 99. And then I'll do the same on switch 1. Switch port trunk native VLAN 99. Let's return to the link now and start the packet capture. And once again, type DTP in the search bar. What I'm expecting this time, as I said in the lecture video, is that the frames will be tagged in VLAN 1, but not with an ISL tag, with a .1q tag, even though regular data frames will be sent with ISL tags. As you can see on this DTP message, it has a .1q tag with ID 1 for VLAN 1. If I click on the DTP message itself, and then trunk type, you can see the port is using ISL, but the DTP frame itself is tagged with .1q. Okay, that's all for step 3. Let's return to the lab notes for step 4. Examine the DTP frames sent from switch 1 to PC 1. What VLAN are they sent in? So I'll click on the link between switch 1 and PC 1 and do a frame capture, and once again type DTP here to display only DTP frames. Because PC 1 doesn't use DTP, I'm expecting switch 1 to actually send 2 DTP frames every 30 seconds. One untagged, and one tagged in VLAN 1, but this time with an ISL tag. Let's check. So this first DTP frame does not have a tag. How about the second one? This one has an ISL tag, as you can see here. If I view the contents, you can see the VLAN ID here, VLAN 1 as expected. This behavior seems a bit quirky to me, but that's how DTP works. I will say once again that, in a real network, you should just disable DTP and manually configure trunk and access ports. However, DTP is a topic on the ENCOR exam, so you should spend some time getting familiar with it. Make sure you know the result of each combination of administrative modes: access, trunk, dynamic auto, and dynamic desirable. One final thing. Let me point out the TLVs I mentioned in the lecture video by opening up this DTP message. Here we have domain, trunk status, trunk type, and sender ID. Each of these is a field in TLV format: type, length, value. I'll open up domain. The type is domain, indicating that this field says the VTP domain. The length is 5, meaning that this field is 5 bytes in length. And the value, the domain, is empty, because the VTP domain is currently null. Trunk status is another TLV. The type is trunk status, the length is 5, meaning the field is 5 bytes in length, and the value is access auto. So that's how TLV fields work. I'll mention TLV again when we cover LLDP, Link Layer Discovery Protocol, later in the course. Okay, that's all for this lab. In the next video, we'll continue the topic of VLANs by looking at VTP, VLAN Trunking Protocol. I hope this video was helpful. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Yonatan Makara, Velva Jacob, George Streeter, Funny Dart, Nasir Chowdhury, Devin Suku, Gustavo B.R., Gerard Baker, Marcel Lord, Pavel M., Mr. Erlison, Dragos Hernea, Zakib Shah, Mayor Salman, Mason Anderson, Vitaus194, Gina Lindley, Mark Jackson, Bold1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Maratuba, Roji Kuriakos, Arpad Konives, 5 Feet, Owad, Daniel Brown, Tricky Mickey 123456, Scott Thompson, Jose Alvarez, Kevin Hayes, Hussein Yavuz, Samuel Tavares, Roger Bratseth, Mustafa Irsoy, Nasser Zahar, Brian Grant, Kyle, Georgi Gemejev, Dibya Swain, Arlen Plagaria, Dear Diso, Adelson Pereira, Farad69, Lucian Stoichitoyu, Madmark50484, Sean Powell, Alexandru Stratan, Hiago Bicalho, Abdo Zizo, Piotr Kaimov, DMJ2, Kurt Nell, Preeti Dongave, Omed Farakesh, Steve Cox, Jasper Yim, Wilmer Romero, Enigma G, Laurent Lam, Emmanuel Nupsido, King Doka, Pedro Harmon, and Ivano Capuano. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So, if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.